So actually, this is the outline of chapter 28. Okay, so we will introduce what is magnetic fields. Okay, so as I mentioned, so in this textbook, it tries to call B field as magnetic field, but if you find some material on the internet or other textbook, more precisely, the magnetic field should be the H field rather than the B field. Of course, H field and B field have a ratio between these two variables, between these two vectors. And this textbook always call B field to be magnetic fields, and it don't have this H field in this textbook. So anyway, I will simply call B field to be B field. Try to avoid calling B field to be magnetic field. And if you find the correct name for the B field, it should be magnetic flux density. Yeah, but if I still try to call it magnetic flux density, you may be confused. But because in this textbook, it always try to call it magnetic field. Yeah, so later on we will talk about cross field. Okay, so it's the discovery of an electron, and the cross field, the Hall effect. Hall effect is to verify the charged particle in the conductor should be negative charge rather than positive charge. Before that, the scientists consider the current to be a moving positive charge. Yeah, but so for most of the case, you can just consider the positive charge moving in this direction or the negative charge moving in the opposite direction. It's okay, but the Hall effect tells you that it can only be negative charge moving in opposite direction, but not for the positive charge moving in the forward direction. So yeah, so this is a very important experiment. And next we will talk about the circulating charge particles. So yeah, so in the cross field, and then we'll talk about the cyclotron and synchrotron, 就是一些粒子加速器 particle accelerator. And then we'll talk about the magnetic force in a current wire. So it is another type of the Lorentz force. Okay, so we'll talk about what is Lorentz force, and then we'll talk about the torque on a current loop, and then the magnetic dipole moment, similar to the electric dipole moment. Okay, so this is the B field. B field can be defined as to be a vector or quantity that exists when exert a force Fb on charge moving with a velocity v. Okay, so similar to the Lorentz, similar to the Coulomb's force. Okay, so in chapter 21, we actually learned the Coulomb's force, which means that if we have two charged particle Q1 and Q2, no matter it is positive or negative, there will be force acting. Yeah, there will be force interacting between these two charged particles. Okay, so in this case, if we put a charged particle in the B field, okay, if the charge doesn't move at all, there will be no force acting on this charged particle. But if this charge is moving in a uniform velocity, then there will be a force acting on this charged particle. And yeah, even stranger is that this force will be perpendicular to the velocity. Okay, so it makes things even more complicated. So in such a way, we have this one, B equals Fb over Q times V. Okay, so we try to define the B field like this. So which means that if we try to put a charge with a velocity V, okay, so we know this V, and then we know the charge amount. So we try to measure the force acting on this particle. So this ratio will be the B field, the magnitude of the B field. Okay, so if we try to write it in a vector form, so we will have Fb equals QV cross B. Okay, so we have a cross product here. And this Fb, this force, we call it Lorentz force. Lorentz force. Fb on the particle by the field B is equal to the charge Okay, this is the charge amount, and then times the cross product. Okay, this is a cross product of the velocity v and b. Okay, so I suppose in high school physics you should have learned what is a cross product. Okay, but yeah, even though if you haven't learned it yet, it's still okay. So, but anyway, so this Lorentz force is related to the operand of a cross product. And for this cross product, if we just consider the magnitude, so if we write in a scalar form, FB will be QVB. VB will be the magnitude of vector V and vector B. Okay, and here we also have a term psi of phi here, psi of phi here, and the phi is actually the angle between V and B. Okay, so we need to multiply by the vector psi of phi. So for this cross product. Okay, so most important thing is that we need to determine the direction of the forces of the vector. Okay, especially involving this cross product. So if throughout the magnetism in chapter 28, 29, 30, okay, we will talk about many different directions. Okay, we always use the right hand rule, 右手法则 to determine the direction of different vectors. Okay, so in this case, suppose we know the direction of V, we know the direction of B, then we will be able to determine the direction of V cross B. And then finally, if Q is positive, then FB have the same direction as V cross B. And if Q is negative, then FB will have the opposite direction as V cross B. So it is important to know how to determine V cross B. Okay, so this is this figure shows you how to determine V cross B. Okay, so first of all, you know the direction of V. So you use your forefinger, follow the direction of V, and then you also know the direction of B. So you use your hand, okay, to sweep to the direction of B, and then your thumb, okay, so this is the first step, pointing to the V, and then you'll sweep to the B, and then finally your thumb will point to the direction of V cross B. Okay, so this is the direction of V cross B. So V cross B must be perpendicular to both V and B. Okay, and if Q is positive, then FB will have a same direction as V cross B. If Q, so here it says the force on a positive particle, okay, and then a force for a negative particle, which means that if Q is negative, then FB will have the opposite direction as the V cross B. Okay, so this is the right hand rule. The only thing we need to pay attention is that we need to consider this angle. This angle phi should be larger than or equal to 0 degree and less than or equal to 180 degree. Okay, so don't try to make an angle larger than 180 degree. You can also try to do it or make it like this, and then I rotate for most of the time, and then and then my thumb will point in the opposite direction. So this is not correct. So you need to guarantee that the angle you sweep is between 0 and 180 degree, so that the direction of V cross B will be correct. And another thing you need to consider is that even though it is a cross product, it's a multiplication, but you cannot exchange the order. You cannot exchange the order. Okay, V cross B and B cross V are different. With a sign, with a polarity. Okay, so if you exchange the order of cross product, then you have a additional negative sign. Okay, so here we can we can somehow explain the physical meaning of the cross product. So for the cross product, if we have a V and then B like this, of course V cos B will have this direction. Okay, so use a right hand rule of V cross B, and then your thumb will be pointing upward. Okay, so what is the magnitude? The magnitude of V cos B will be this parallelogram， 就是平行四边形的面积。这个面积this area will be the V cos B，V cos B. Okay, equals VB sine theta. Yeah, because in high school trigonometry, you know, if this is V, this is B, this is phi, this is phi. Okay, so this the area of this triangle will be 1/2 VB sine phi. Okay, so this one is VB sine phi. So this is 2 times of this. So this is 1/2. This is another 1/2. So this is a parallelogram. The area of a parallelogram. OK， 所以这个是这个平行四边形的面积 ，area of the 平行四边形 ，OK，parallelogram。那之前我们学的这个 dot product 如果我们有 A 向量 B 向量的 dot product A dot B，A dot B。Okay, if we take the absolute value, will be AB cosine of theta if the angle is theta. Okay, so if it is A, this is B. So this projection is like the B cosine of theta. This is B cosine of theta times A. Okay, 所以就是 A 乘以 B 在 A 上面的投影，就是那个 inner product。那这个叫做 dot product 没有这个绝对值，就是 dot product 的话，它出来的话就是 scale。那 cross product 的话，它的结果还是一个向量，就是 cross product 还是给你一个向量。Okay. Yeah, I think I can also supplement something like the cross product for the unit vector in the Cartesian coordinate. So we will have let's say I cross J, and then I cross K, and we actually have 9 combinations: J cross I, and then J cross J, and then J cross K, and then K cross I, K cross J, and then K cross K. Okay, we all together have 9 combinations. Okay, so first of all, we will have this one to be 0, this one to be 0, this one to be 0. And then I cross J will be K, J cross K will be I, and then K cross I will be J. And then I cross K will be negative J hat, J cross I will be negative K hat, and then K cross J will be negative I hat. Okay, how to remember this? Actually, you can use a simple circle to really remember. Okay, something like you can write I, J, K like this. Okay, so if you have the cross product, something like this, in the clockwise direction, I cos J will become K, J cos K will become I, k cos I will become j. Okay, so in this direction, all are positive. But if it is in the opposite direction, like this, if it is I cos k, k cos j, and then j cos I, in that direction, in the counterclockwise direction, there will be a negative sign. And if it is crossing itself, then it will be 0. It will be 0. Because sine of, if a vector is crossing with itself, this angle will be 0 degrees. Sine of 0 degree will be 0. Okay, so I cos I, j cos j, k cos k will be 0. Okay, so this is the cross product for the unit vector in the Cartesian coordinate. So it will be somehow useful. Okay, so yeah, so magnetic field. Okay, so this is a quick summary. So it says the force Fb acting on a charged particle moving with velocity v through a magnetic field B is always perpendicular to V and B. OK， 就是这个或者是 V cross B 一定会跟 V 还有会跟 B 垂直。V 跟 B 互相不一定垂直，但是它们的 cross product 一定跟它们本身垂直。Okay, so this is a quick practice. Okay, so we can try to figure. The figure shows 3 situations in which a charged particle with velocity v travels through a uniform magnetic field B. In each situation, what is the direction of the magnetic force Fb on the particle? What is the direction of the Lorentz force? Okay, so for the first one, this is positive, and then the v point to the negative x-axis, and then this point to the negative y-axis. Okay, so we can use both ways. Try to use the right hand rule. Use our hand to determine the direction. Okay, so first of all, you can use. Let me see. Okay, v pointing to the left side. Okay, so we use our finger pointing to the left side, and then we try to cross to the B. So your thumb will be pointing out of the page. So this is V cross B, and then the charge is also positive. So which means that okay. So actually this FB point to the positive Z axis. Positive Z axis. And one thing you can notice is that actually this XYZ coordinate also follow the right hand rule. Okay, this is positive x-axis, this is positive y-axis, this is positive z-axis. So if you point to the positive x-axis, cross to the y-axis, then your thumb will point to the positive z-axis. So x-axis and cross x-axis, x, y, z axis also follows right hand rule. So in another way, we can use the unit vector notation to really determine the direction of FB. Okay, so here we can see that V is actually pointing to the negative x-axis, so it can be negative V I hat, negative V I hat. Okay, pointing to the negative x-axis, and B is actually pointing to the negative y-axis, so it is negative B J hat. So FB equals QV cross B. Okay, this is positive. This is okay. So this will be QVB, and then we have a negative. So we have a positive, and then I cross j. I cross j will be k hat. So it will be qvb and then k hat. Okay, so in this case, k hat is the positive z-axis, which matches what we did before. And for the question B, okay, this is a negative charge. This is V, this is B. Okay, so we use our hand pointing backward and then cross to the B field. Okay, so V cross B pointing still out of the page, but the charge is negative, so which means that FB is pointing into the page. Okay, so in this case, not into the page. So yeah, so V cross B point to positive x-axis, positive x-axis. So FB point to the negative x-axis, negative x-axis. Okay, similarly, we can use the unit vector notation. So in this case, V is pointing to the negative y-axis, which is a negative V, and then negative y-axis is j hat. Okay, and then B is pointing to the negative z-axis, which is negative b k hat. Okay, so FB this is a negative charge, so we write it as a negative q V cross B. Okay, so we count negative, negative, negative. We have 3 negative, so it is still negative QVB, and then we have V cross B, J cross K. J cross K. J cross K will be positive I. So finally it becomes negative QVB I hat. Okay, so this is negative x-axis. And then finally, this is VB pointing to the opposite side, so which means that this phi is 180 degrees. So this is a zero vector, so no direction. Okay, so let me end today. So we'll see you tomorrow. I'll see you.